Hi. All right. Well, let's talk a little bit more about conversions of the larger units of measurement to the smaller and vice versa. And let's also look at power. So hopefully the metric system is making sense to those of you that it's new to. And let's figure out what we need to do as far as power. Now, this should look familiar. We talked a little bit about this already. E over IR. Of course, this is voltage. I is current. R is resistance. So if we need to find voltage when we know current and resistance, we can figure out how. If we need to find resistance when we know voltage and current, we can do that. There's another one that you should learn, and notice that they are different, but we use the same pi setup to help you remember it. P equals power. That's what we're adding to the equation now. Power, E still equals volts, that's right, and I still equals current. Very good. So P over EI, or P equals EI. All right, so if you know the power, you cover the P. Or I'm sorry, if you're, I cannot speak what I'm thinking in my head this evening. If we're looking for P, we cover the P, and power is going to tell us that we multiply volts times amps. Electromotive force times current. So that would be power equals EI. There we go. That makes a little more sense. Let's look at some questions and we'll get through this a little easier. We'll use questions that are in the question pool. So one of the questions I'll start with here, it says how much power is represented by a voltage of 13.8 volts DC. Now this equation only works with DC volts. So if you have AC volts, that's not going to work in this equation, so it has to be DC. And all the questions are DC volts, so that should be fine for you. How much power? We want to know the power, so we'll cover that up. How much power if there's 13.8 DC volts and a current of 10 amps? Well, EI means multiply, right? So 13.8 volts times 10 amps is going to be 138. What is power measured by? The unit of measurement for power is watts. So you just answered the question. The answer to the question is 138 watts. Multiply volts times amps. So if you can remember this little equation, that will help you. Let's look at another question. How much power is being used? What we're looking for? Power. How much power is being used in a circuit when the voltage is 120 volts DC and the current is 2.5 amps. Well, again, we're looking for power, so we multiply EI. 120 volts times 2.5 amps is going to give us, if you do your calculator or law of multiplication, you're going to get 300 what? 300 watts. All right, let's keep going through these questions. Here's a little different one. It says, how can you determine how many watts are being drawn by your transceiver when you are transmitting? All right, so I want to know how many watts, how much power I'm drawing on my transceiver. How do I find that out? Well, you've got some options there. Check the fuse and the power leads to see what size it is. Well, that's just going to tell you what current will set off the fuse. Look in the radio amateur's handbook. Well, that might tell you how you should find this out, but there's a better way. Just learn the equation here as to how to find this out. How would we find total power? Well, power equals what? Voltage times current. So if we can figure out the voltage and the current, we can figure out how much power our transceiver is drawing. So I'll measure how many volts it's drawing, and for a better example would be to actually use this little mobile radio. Let's say this little mobile radio is drawing 13.4 volts DC. Okay? And what I did is I took my little voltmeter, here, and I stuck it up to the power supply on the leads that are coming out to the radio. And I noticed that there is a draw of 13.4 volts DC. Now what if and then I need to figure out what the current is that's going out. Well, let's just say that I figured out that we're looking at 3.4 amps. Okay, let's just say I figured that out and guess that way. And so what we're going to do, of course, volt DC times amps equals power. So we're going to multiply these. 13.4 times 3.4 equals 45.56 watts. Well, that's about right. A radio like this on high power is going to do 50 watts on 2 meters. So it looks like, I'm in the right ballpark. So that's how you can figure out. So remember, how do you find out the power to your transceiver? You're going to multiply the current times the volts. This equation. So if you learn that equation, that'll get you a long ways. All right, let's look at some more questions. How many amps are flowing in a circuit when the applied voltage is 120 volts DC and the load is 1200 watts? Oh, it's a little different. They've given us the watts and the volts. Okay, so what is it we don't have? Current, I. So we cover that up. P over E. Well, P equals, in this case, how many watts are we talking about? 1200. And E, or volts, equals 120 volts DC. Okay, so what is it? P over E. 1200 divided by 120. What's that going to give us? That's going to give us 10. So the answer is 10 what? What unit of measurement? We're looking for current, remember? So it's going to be amps. 10 amps. And there's your answer for that. Now, let's go ahead and take a short break here. And we'll come back and we'll do some of the questions that have to do with conversion of the metric system for smaller and larger units.